So here's this week's installation of the building of the H24/H12 engine. See, I've done more work on the top frame there. It's still not welded to the bottom frame, but that's because I want to be able to flip it around and weld things upside down, different things. But it does have the 6 engine bases welded to it now. You can see here 2 of them there with the chain on it. Just wanted to check chain clearance to the frame and see my exhaust pipe there. Have to bring the exhaust out that way versus straight, because on the front engine there'll be an intake manifold 90-degree elbow like this that'll come along this way to the next engine. Now on the third engine in a row, I could bring the exhaust out straight like this one, because the intake manifold will be coming from the front. But hard to say. To make them look the same, I may just direct them towards the back that way. I don't know. But I've been learning a lot about what my little MIG welder can and can't do. It's not bad welding things like this with 35 thou flux core, but it's not so good at plug welds. So I switched to 24 thou solid wire for the first time, and see this gobbed up mess here. Underneath it there is a 35 thou flux core weld like that, so it's welded, but then when I tried to weld on top of it, yeah, I don't know. I'm not getting any penetration with the solid wire. It's great for welding thin things, but I seem to have to use flux core to weld, and I've only got an 88 amp welder, so I think that might be part of the problem too. So I left 3 of the 4 plug welds open, and I'll probably get them done with my son's 140 amp welder. And the other thing I may do is put in a couple of countersunk 1/4 inch safety bolts, just in case all the welds let go. It would still have 2 bolts holding it to the frame. So probably will go ahead with that. It'd be a lot of work, but better safe than sorry, right? I don't want to see the thing implode on itself here. Motors flying through the air, chains wrapping around things. Could be a bad scenario. Anyway, so I am making progress in spite of the weather. The weather here has been horrible for this time of year. 1/2 inch of snow on the ground yesterday morning. It's currently, I don't know, 48 Fahrenheit or something. Rainy, snowy, windy, so it's terrible weather for mid-May. In spite of the fact there's my tulips and daffodils are up there. Well, hopefully it'll focus in. I don't know. You can see them. So lots of flowers out, but it's bad weather. You can see these guys here coming up. Anyway, the other thing I've done this week, because the weather's been so bad, so the one I'm building is based on the Napier Sabre, which is a flat H24, got piston here, 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 and here, so double crankshafts. And I actually colored in a section drawing of it, so that took a number of hours to do. And its rival at the time was the Rolls Royce Vulture. I believe I've already showed this colored in Vulture that I did. But the Vulture made by Rolls, even though they made 500 and some of them and flew them, they are basically extinct. They've there's hardly any information on them. So what I'm doing here is making a cross-section drawing of the Vulture. This is actually based on 2 Rolls Royce Merlins. I cut and hacked and redrawing all this crankcase area and the connecting rod. One of the big problems with this engine was the connecting rod design. You had to use very small bolts, small short bolts, just because of the funky geometry of it there. So next comes the intake manifolds. Oh, the wind's picking up here, and I knocked off the heaviest paperweight there. My son's an NC machinist, and this one was a paperweight that he made there. I guess the one dimension on it wasn't quite right or something, but anyway, comes in handy for holding papers down since the wind seems to want to pick up. But anyway, this here will probably be like, the only semi-accurate cross-section of the Vulture in existence. Like I say, it's not totally right, but at least it gives you an idea. And the connecting rod area seemed to be one of its big problems, whereas the Napier Sabre, the Vulture had 24 connecting rods on one crankshaft, so the Sabre only had 12, and they just used standard fork and blade rods. That's where one connecting rod's a U shape, and the blade rod fits inside of it. You can kind of see it here. There's not a bad example of it up there. Up here, you got the U-shaped rod and the one on the other side. Rolls Royce Merlin and Griffin, a lot of the engines used the fork and blade type connecting rod. But this one is more like a radial engine, but worse because it's at 90 degrees, whereas radials are odd angles. They seem to be able to successfully make the connecting rods. But anyway, just show you the colored in Vulture there, and my latest colored in Napier Sabre. So I have been busy, and I made all 12 base plates for the motors. That actually took at least a few hours to do. Drilling, let's see, you got 8 holes per plate times 12, so there's 96 holes. And yeah, the numbers on this are fairly impressive. Like, even with a 12 cylinder at 4 bolts each, you'll have 48 bolts holding the motors down. And same thing, 24 intake manifold bolts. And yeah, I had to do a lot of bolt shopping before they closed the hardware stores down. Luckily they opened them back up yesterday. I didn't need anything that I'm aware of right now, so I didn't go in, but at least COVID seems to be backing down a little bit, which is good. Maybe not in all areas though, so just play it safe still, or keep your distance and all that. So I'm out here by myself, so everything's doing all right. But anyway, that's this week's installment of the H24 engine build. So I'll keep on working on it. I think the next thing I'll try to do is fit in the mounts for the timing shaft that goes down the center, that the chain attaches to, going to all of the engines. So anyway, everybody take care for now, and I'll keep working on this. Have a good one. Well, just making base plates for the 12/24 cylinder for the horizontal type motors there. I'll just set that down. So there's a base plate with 4 holes on it. It's 3/16 steel. So I cut all 12 of them out, and then I discovered this set of transfer punches that I got a few years ago for Christmas. So I got 6 of them drilled out now, and I'm starting on the second batch that I just cut out this morning. So I got the transfer punch there, and basically you just put it in the hole and smack her on the end to mark it there, and I go around. Got them clamped in the vise together so it can't move, and go around there and do all 4 of them. And then I got a bunch there that have already been marked. So before long here I'll have 12 base plates, and I do the same thing for the intake manifold pieces there and everything else. Got to admit, these transfer punches sure do come in handy when you're making things like this. You see one there, I believe that's a carburetor mount there that I've got in the works there. So anyway, it's been kind of cold out here this week. Had some half-inch of snow this morning, so it's kind of slowed me down a bit, but I'm still working away on the frame to support all of these engines here, so I'll show more about that. So I'm just about 3/4 of the way through drilling the plates here. I just want to mention the drill bits I'm using. I actually pre-drill with an 1/8" bit. Kind of like a center drill, but it's just a 1/8" drill bit. Then I'm using a 5/16. It's a Vulcan cobalt drill bit. Got these last year and bought them on the internet for 20 bucks. Just a 16th through 3/8 set, and I'm really happy with them. They seem to work very well on steel. So as you can see, I got a stack there with 4 in each one, and there's another 6 plates there. So let's see, so I got to drill 48 holes total just in these plates, and it's not showing any signs of getting any duller than it was at the start. It takes me about 10 seconds to drill through 3/16 plate. I don't have the biggest drill press here, and you know, I just take my time at it, but that's moving at a decent speed. So I'm happy with these cobalt drill bits, and I think I'll be buying some more. I could use this 5/16. I could use just a hair bigger than that, maybe in between that and 3/8. Give me some clearance on the 5/16 bolts. But anyway, I find these cobalt bits work very well. I also drill a little bit of stainless steel the odd time, so it's good to have them for that also. So I'd highly recommend cobalt bits. I can't say there isn't any cheap ones out there, but these Vulcan ones, they weren't that expensive, and they seem to work just fine for me. I bought a lot of the gold colored ones there, the plated drill bits, and I don't know, I haven't had a whole lot of luck with them, but I gotta admit, these cobalt ones, they really cut. Never seen an ice pattern like this on my car roof before. It sure is strange. Anyway, there's a couple things that shouldn't really be seen at the same time. So you got this, and we got all kinds of daffodils at the same time. So quite the frost we got going on here today. Especially for what, 8th of May. Poor little tulip trying to fight his way up there. But my field of daffodils with ice on them. I'm not impressed.